Hi everyone. Section 20.6 is all about the inverse trigonometric functions. We've worked with inverse trig functions before when we were solving equations. Now we're going to kind of formally define the functions and think about what their graphs would look like, but just look at them more in depth. I'm going to go through one example. We're going to look at cosine and define the inverse cosine function. The rest of the trig functions is a similar story behind those, and you can look in your book if you want a more in-depth explanation for those. All right, so cosine. We know that the graph of cosine, y equals cosine of x, looks like this, right? And it keeps going, right? This wave keeps going in both directions on both sides. You learn in algebra that in order to be able to define an inverse function, or in order for a function to be invertible, the function has to be 1-to-1, which means that it has to pass the horizontal line test. That means that a horizontal line drawn anywhere on the graph is only allowed to cross the graph one time. Is that the case for cosine? If I draw a horizontal line through this, is it going to cross the graph more than once? Right, here's a horizontal line. Heck yeah, it's going to cross more than once. We see 1, 2, 3, 4, and this continues, so there's actually going to be an infinite amount of times it would cross. So that means that we can't define arc cosine, or the inverse cosine function, for our normal y equals cosine of x graph. We're going to have to really cut the graph down in order to be able to define an inverse. So to do that, we are going to look at just a piece of the cosine graph. We're actually going to look at cosine just for the values between 0 and pi. Okay? So I'm going to graph this. I'll be a little more specific about this. What's the value at cosine when x is 0? It's 1, right? We have a point there. Then cosine comes down, crosses the x-axis at pi over 2. And then at pi, the value of cosine reaches a minimum value at -1. So this is a piece of the cosine wave that looks like that. All right, now to define an inverse function, what you need to do is you switch your x and y coordinates. I'm going to draw what that would look like. So what we would be creating now is a graph for the inverse cosine by switching these coordinates. What are these coordinates? Well, let's write them down here so we can switch them. We have the coordinates 0, 1, pi over 2, 0, and pi -1. So if we switch those, we're going to have the coordinates 1, 0, 0, pi over 2, and -1 pi. Of course, those aren't the only points on the graph, but those are kind of what we're labeling as our important points on the graph. All right, let's plot these and see what it looks like. So 1, 0, we'll put that right here. So we'll say that's 1. 0, pi over 2, put that right here. So that makes this pi over 2 on the y-axis. And then -1, we'll say -1 is right here. And we're up at pi. So we'll say pi is here. So we have a point right here. And we have our piece of our arc cosine curve now. Actually, this is our entire arc cosine curve. Which means, look at this. Okay, what is the domain and what is the range for this graph? you can see the domain, right? The x values on the graph range go from -1 to 1. The range, what y values, what y coordinates do we see on our graph? Well, this graph starts at 0 and it goes up to pi. All right, so that was interval notation. As an inequality, it would be written like this. All right. So that means that if you plug values, the only values that can be plugged into an arc cosine function are values between -1 and 1. If you try to plug in something outside of that, it is not going to work. You could test this on your calculator, right? So if you grab your calculator, if you're following along, if we type in arc cosine of, pick anything that's outside of -1 to 1. So I'm going to put 5 in there. Arc cosine of 5, domain error, we can't do it. Now if you put something in there that is in between -1 and 1, then say 0.4, I don't know, you're going to get an answer. And that answer that you get will always be between 0 and pi, right? Or roughly 0 to 3.14. Okay, so over here, this box, you probably want to take a minute to pause the video and write these down in your notes. This has all of the inverse trig functions and then their range. It's going to be important to know the range for the next thing that we do in this section, because we're going to be evaluating these functions at certain, for certain values of x. And you need to know that these are the values that you can get as an output, okay? You're going to want to have this written down somewhere. If you're able to print the notes for this section, the notes for this section are posted online, and there's an answer sheet also posted online for this. That has this table on it, okay? So if you wanted to print that instead of writing it down, that would be okay as well. But as long as you have access to it, we're in good shape. Alrighty, I'll see you in the next video.